Hey everybody, it's Mr. Simone. The purpose of today's video is to be able to identify the domain and range when you are given a graph of a relationship that is continuous. Sometimes our relationships, when continuous, are actual functions, and sometimes they're not. So we'll kind of talk about both of domain and range, and also is the relationship a function. All right. In these cases, anytime that you have a solid curve or solid line, you need to know that they are considered continuous. There's infinite amounts of points that are all connected. All right. It's not like discrete where you have distinct points. It's a slightly different way of writing domain and range. You can use inequalities, but one of the things we do in our class to make life a little bit easier is to use what's called interval notation. So interval notation is looking at the start and the end for your x values and the start and the end for your y values. And we're going to take a look real quick at this. So when we talk about domain, domain is all of your inputs, which represents your x values. So we're going to look at our x-axis, and you're going to want to look at from left to right. I almost think of like a picture frame. What is the farthest left that our x values start with? And if you look at our x values, you'll notice that there's a point here, and we start at -2. So our domain is going to start at -2. And when it ends, a little bit tricky, is when you look at the x-axis, you'll notice that this arrow pointing on our functional curve here, our arrow is pointing up, which means it's going infinitely up, but also infinitely in the x direction. One of the things we talk about is, well, we have our relationship of our domain. Our starting point is -2, which is inclusive. We use a bracket. And infinity you can't really contain because it's always changing. We use a little bit of a parentheses. Okay. If I was to write this using inequalities, it would be all x values that are bigger than or equal to -2, but less than infinity. Okay, meaning that it's going to go on infinitely in that direction. For our range looks at the y values, so your y-axis, and I often tell students think about like an elevator. Okay, our elevator starts at the bottom floor with the lowest it can possibly be, meaning the lowest y value. And if you look where our function curves down and then back up, it starts at -4. -4 is inclusive, and you'll notice that this curve continues up infinitely. Many times kids think that it stops at +2 because our point stops at +2, but actually, because that arrow shows that we're going infinitely in the y direction, we do end up going up. So that's one way to kind of think about your domain and range. If you were to use interval notation, it's all the y value. To use inequalities, it would be all the y values that are greater than or equal to -4 and kind of like less than infinity because it is continuing in that direction. If we end up looking at our domain for the second one, you'll notice that this curve is in fact a function. And it's kind of the same idea. Domain is all of our x values. Farthest left we have is 1. Oops, see, nope, -2 in the x direction. And we continue on infinitely in the other direction. It's always that idea of like left to right and then down to up. Our lowest y value when we look at our range, our lowest y value is going to be +1. It is inclusive. And because that arrow is pointing up, just like we had in the last example, it is infinite. In the third example, all right, we have a function. We can notice that it goes kind of infinitely in this direction because of the arrow, and it also stops right around here. You'll also know that there's an open circle, which is different than some of our closed circles, and it might be hard to see through the video, but there is an open circle in this position. So our domain, if we're thinking about our x values, our domain, the farthest left is infinitely in that direction, which is considered -infinity. So -infinity, because again, this arrow says it's going up and over, all the way to 4. You'll notice that at 4, or x is 4, the relationship is -16. But because of that open circle, because it's an open circle, it's not inclusive, we use a parenthesis to show that it does not include it. Our range is the lowest possibility to the highest possibility on your y-axis. We talked about -16. It's not inclusive because there's an open circle, so we have to use that parenthesis. And it is going in this direction with an arrow, meaning that it's going to go up infinitely in the y direction. So infinitely in the y direction. All right. So these are three functions using interval notation, and sometimes when you're going through these problems, you tend to mix up if it's a discrete or continuous function. Sometimes there's things called piecewise functions, where it's a function made up of separate pieces. There might be holes or gaps. But in this case, we're looking at a continuous function. Sometimes there are, in fact, limits. Okay. We're going to look at a couple more. I'm going to kind of go through them for you kind of quickly. So number 4, this example, this is not a function. It doesn't pass the vertical line test. If you drew a vertical line in, it doesn't pass the vertical line test because our input of -2 has multiple outputs, which by definition is not a function. It is a relationship though. So our domain, you can still figure out domain and range even if it's not a function. Our domain, if you look at our x values, the farthest left, you'll notice there's an arrow here pointing in that direction, is going to be -infinity. Pointing to the right, if you look at our x direction, if you follow this curve, it is infinitely going in the positive direction. Again, it's not containing those, so we have to use parentheses to show that. In the range direction, it does look like this arrow is kind of continuing in the negative direction. So the lowest possible y value we can have is -infinity. And the positive, if we look up in the y direction, although it kind of looks like it's flattening out, it looks still like it's going up. So this is also going to be positive infinity. This one right here, number 5, is a function. Again, domain is our x values. You're going to notice that there is a curve, there's an arrow, there's an open circle, so all things we need to think about. In the x direction, this is going to be -infinity is the smallest amount because that arrow is pointing down and over. And as we move to the right, we're going to hit 3, but it does not include 3. If you can't see on the video, it's an open circle. So 3, not inclusive. For our range, the lowest possible value, if you think about an elevator on the y-axis, is it's going to be -infinity. Because again, but this little arrow means it's pointing down, so you can never actually get that starting value. It's infinitely in the negative direction. As we move up on the y-axis, we eventually hit +16. And +16 has an open circle, so again, it's not inclusive, but it is a limit that we're going to see. All right, the very last one that I'm going to do today for this video is our domain. We're going to look at our function. This is a linear function. We are going to start in the x direction. The farthest left you go is -4. You'll notice it's inclusive. All right, so we're going to make a bracket. It heads in this direction, in the negative direction, infinitely in the x direction. And then for our range, similar to this kind of problem, our range is going to be -infinity, the lowest possible y value, and the highest possible y value is 2, which will be inclusive using a bracket. So this is domain and range for relationships, for continuous relationships. Again, some of the relationships are functions, some are not. We can still identify domain and range, but this is interval notation. It's a strategy that we do use in class. Again, you could use inequalities. We tend to lean toward these for your help. All right, keep watching.